Okay, Math at Work 10. This is actually your last official lesson for our online learning, so this will be your last video lesson that you'll need to participate in. In this lesson, we'll be looking at using the trig ratios that we've been talking about in the last few lessons, but this time to determine missing angles. Right? So far we've been dealing with using those trig ratios of sine, cosine, and tangent to find missing side lengths of a right triangle, and now what we're going to be doing is using those same ratios to solve for a missing angle instead of a missing side length. So like I said, this is kind of your last official video lesson. Again, after this, you'll have a worksheet for practice, and then you'll have an assignment. Okay, so you'll have one final, actually you have two little things. You have one, you'll have this video, then you'll have a little determining angles quiz. Okay, so it'll be like a Google form sheet again. This is kind of like multiple choice. You can get immediate feedback on how you're doing, just on these concepts of sine and cosine, using those ratios to find missing angles and missing side lengths, and then you'll have your final project, which will be posted as well. Okay, and that's just on chapter 7, so everything with trigonometry that we've done. Okay, so the similar shapes, the finding missing side lengths and finding missing angles. Okay, so that's where we're at with that. So we'll just get into the lesson. We'll go through the examples. Like I said, you'll have a worksheet for practice, and then you'll have two final little assessments. One, another Google form quiz on finding missing side lengths and angles using the sine, cosine, tangent ratios, and then your final chapter 7 kind of assignment dealing with everything. Okay, so we can get into that. All right. So as mentioned, in our previous lessons, we've been talking about the sine and cosine and tangent ratios, all ratios between side lengths of right triangles, right? Remember that these can only be used for right triangles, okay? And we've been using them specifically to find missing side lengths. So when we had information about an angle and one side length, then we used it to find information about a missing side length. In this lesson, we're going to use those same ratios, okay, and a different button on our calculators to be able to find missing angles, okay, but again, only in right triangles. So the big thing that you need to know for this one is the idea of what we call an inverse trig ratio, okay, and this is an operation performed on a trig ratio like sine, cosine, and tangent in order to find a missing angle, right? So you're basically trying to find that angle that would result in a particular ratio. So the button we've been using so far on our calculator is just sine, cosine, or tan, and what that does is that, and you might remember this in the lesson, when we talked about using that button, it was this idea that the calculator has stored all of the ratios for sine, cosine, and tangent for all the different angles. And in order to access what that ratio is, you type in the sine or the cosine or the tangent of the particular angle and out spits what the ratio is. If we wanted to do this in reverse, we're instead asking a calculator a different question and saying, look, I know the ratio, but I want to know which angle would give me that ratio, right? So again, if we were to think about what they did before calculators, is they'd have these big tables, and you'd look at it, and instead of looking at the angle and then going across to find what the ratio is, you'd instead be looking down the table of the ratios and trying to figure out which angle matched, okay? So basically there's just a different button on your calculator that's telling your calculator to look up the opposite, saying, I'm giving you the ratio, you tell me the angle, right? And that's what we use these buttons here: sine inverse, cos inverse, and tan inverse, okay? Now that's how we call them, right? That's what we say. We say sine inverse, cos inverse, and tan inverse. We don't say sine to the power of -1 or sine -1. It's the inverse, okay? These are, again, buttons on your calculators. They're typically a second function button, so if you're using your phone, you'll have to hit the second button, and it'll be the exact same spots as your sine, cosine, and tan. And even in like a standard scientific, they're usually the same button, but you have to hit second function. Okay, so again, what it is just an operation that we do that tells the calculator, look, I have the ratio, look up the angle, versus just hitting sine, cosine, and tan, which is here's the angle, tell me the ratio. Okay, so again, it's an operation of kind of like an undoing, right? So if we wanted to undo addition, we would do subtraction. If we wanted to undo multiplication, we do division. If we want to undo sine, we do sine inverse. If we want to undo cos, we do cos inverse, okay? So this is the operation that we do. So in general, our steps for what we do to find a missing side angle, a lot of the steps are the same as what we've already been talking about in finding missing angles. So again, if you're not already provided with a diagram, draw one, right? Using the unknown angle that you're interested in, label your triangle, right? Using the opposite, adjacent, and tangent sorry, opposite, adjacent, and hypotenuse is what that should say. So I'm going to go in and fix that. Opposite, adjacent, and hypotenuse. Okay, so before when we were labeling the triangle, it was with at the angle that we were given. Now we are labeling the triangle with the missing angle, right? So in this example here, right, the missing angle here is x, so we would label our triangle based on that angle. So the 5 centimeters here would be the opposite, the 11 centimeters would be adjacent, and this is of course your hypotenuse because it's directly across from your right angle, okay? So draw your diagram, label your triangle opposite, adjacent, and hypotenuse. Then, based on the side lengths that you have, figure out which trig ratio is relevant, right? So in this case, I have the opposite side and the adjacent side, so which trig ratio involves the opposite and the adjacent side lengths, and that's tan. So I would use the tan ratio, right? Set up that same equation where it's like tan of an angle is equal to opposite divided by adjacent, right? And then solve for the missing angle. Okay, so we're going to do that in a few examples here today. So again, determining which ratio to use is the same process as what it was when it was finding missing side lengths, right? Make sure that you're using the right one, or else you're going to get the wrong answer, right? Hitting sine inverse of a ratio versus tan inverse of a ratio will give you two very different angles, okay? So what you do is, again, you label those sides, right? Determine which two side lengths you will use to find the missing angle, okay? So if you have opposite and adjacent side lengths, use tan because it involves opposite and adjacent. If you have adjacent and hypotenuse, you use cosine because it involves adjacent and hypotenuse. And if you have opposite and hypotenuse, you can use sine. If you have all three of the side lengths, you can actually choose which one you want to use. Okay, so again, your SOHCAHTOA can kind of come in handy there. Again, not just for finding missing side lengths, but also for finding missing angles, basically figuring out which ratio is the best one to use. Okay. So what we'll do is we'll just kind of go through some examples to show you how this works, and then that will be pretty much it, okay? So here we go, example 1. Okay, so we're going to start just by setting up the trig ratios, right? So what does it look like just to set them up? So you can see this diagram here. We have triangle DEF, okay, and we've got the right angle there at E, so DEF. We have side length D here at 5 centimeters, and we have side length D to F, or side length E, here at 13 centimeters. Okay, the question here is just setting up the trig ratio. So determine sine of D and cos of D as exact values and rounded to the nearest hundredth. So once again, what we would do here is, again, we're looking at angle D. D is the angle that we're interested in, okay? So with D, we label our triangle based on this angle. So this would be the opposite, and this would be the hypotenuse, and then this would be the adjacent. Okay, sorry students, just one second. What is it, Jersey? I don't know where that is right now. Can I help you find it later? I'm in the middle of a video. Okay, I'll find it later. Thank you. All right, sorry about that, students. I'll get back to this question. So like I said, since angle D is the one that we're interested in, okay, we label our triangle based on our angle we're interested in. So we're interested in D, so we label this as our opposite side. This is directly across from the right angle, so that's our hypotenuse, okay, and then this would be our adjacent side length. Okay, so it's asked us to set up the ratio of the sine ratio and the cosine ratio, okay? So if we start with the sine ratio, right, the equation is that the sine of an angle, in this case angle D, sine of D is equal to opposite divided by hypotenuse. So sine of D is equal to the opposite side length, which is 5, divided by the hypotenuse side length, which is 13. Okay, so 5 over 13 is the sine ratio, okay, and this would be considered the exact value, okay, because we haven't converted it into a decimal at this point, okay? So if we wanted to get it as a decimal approximation, we're just interested in what the ratio is, so 5 divided by 13, and we would have that sine of D is equal to 0.3846. Now it said nearest hundredth, so that's just 2 decimal places, right? So that's tenths, hundredths, so in that case it would just be 0.38, Okay. All right, now it asks us to find the ratio, the cosine ratio. Okay, so again, the cosine ratio is the adjacent divided by the hypotenuse. And again, we're not asked to find the angle, we're just asked for the ratio here. Okay, so the ratio is just involving the side lengths, right? We'll get to finding the angle in our next example. So just setting up the ratio, what we need is we need the value for the adjacent side length and the hypotenuse side length. So we do have the hypotenuse, we know that that's 13. What we don't have is the adjacent side length. Okay, so this we need to find. Now, fortunately, we have Pythagorean theorem that allows us to find that value. Okay, so we can use our a squared plus b squared equals c squared, right? Remembering that c always has to be the hypotenuse. So we can call this f, because that's how we would label that. And we would say that 5 squared plus f squared is equal to the hypotenuse squared, so equals 13 squared. So that's 25 plus f squared is equal to 169. You'll subtract 25 from both sides because these are being added. So 169 minus 25, and you'll get f squared is equal to 144. And then to undo the squared part, you would square root it. So f would equal the square root of 144, which is 12. Okay, and you also might have recognized this as one of our Pythagorean triples. Okay, so now we know that our adjacent side length is 12 centimeters, so that means that our cosine ratio for angle D, cosine of D is equal to 12 over 13. Okay, and that again would be the exact ratio. 12 over 13 is the exact ratio, and the approximate value would just be doing 12 divided by 13 and saying that cosine of D is equal to 0.92. Okay, and that would be the decimal approximation to the nearest hundredth. So notice how using the same angle, you can get very different ratios, right, depending on which one you're using. Okay, so the sine in this case was 5 over 13, but the cosine was 12 over 13. Okay, so using those different buttons is going to give you different values, right? So you need to make sure that you're using the correct ratio because obviously they're very different, all right? Okay, so those are your values. Again, those are your answers. And now we'll move into another example. Okay, so in this one, we'll actually find the missing angle. Okay, so determine the measure of angle G and angle H to the nearest tenth of a degree. So that would be 1 decimal place. Okay, so again, we make note that it is in fact a right angle, right? Because this process that we're dealing with only works for right angle triangles, right? The sine, cosine, and tangent ratio as opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent only works for right angle triangles where a hypotenuse actually exists. Okay, so if this is example 2, we have triangle GHK, where we have our right angle at angle K, side length H or G to K is 6 centimeters, and the hypotenuse or G to H, side length K, is 14 centimeters. And we're being asked to find what is angle G and what is angle H. Okay, so let's do that. So going through those steps that I discussed, the first thing you need to do is you need to be able to label your triangle based on the angle that you're trying to find. So let's assume we're trying to find angle G first, okay? So if we try and find angle G first, we start by labeling our triangle. So if this is G, going directly across, that would be the opposite. The hypotenuse is always directly across from the right angle, so that would be the hypotenuse, and that would mean that this 6 centimeters is our adjacent side. Okay, so that's our first step, using the angle that we're trying to find. So we've started by finding angle G. We label our triangle. Then look at the side lengths that you have. Okay, now we could find the opposite side length using Pythagorean theorem, but as of right now, we have 2 side lengths already given to us, so why would we do more work? Okay, so we have the adjacent side and the hypotenuse side. Which trig ratio involves the adjacent and the hypotenuse side? And a quick check at your formulas again, and you'll see that that's the cosine ratio. So what you get is cosine of angle G is equal to the adjacent divided by the hypotenuse. Okay, so we don't know the angle, so it's cosine of angle G is equal to 6 divided by 14. Okay, now this is where the inverse trig ratio that I mentioned comes into play. Okay, so we want to try and get g by itself. Now, these things aren't being multiplied, right? Cosine isn't a number. It's not a thing you can divide by. You can't just do divide by cos because cosine is of an angle, right? It's like an operation. So to undo a cosine, you need to do a cos inverse, okay? So what you're doing here is you're essentially taking the cos inverse of both sides, right? You're doing cos inverse of cos of g is equal to cos inverse of 6 over 14, okay? A cos inverse and a cos will cancel each other out, leaving you just with angle g, and then this can get punched directly into your calculator, okay? So you can either go directly as like cos inverse and then bracket 6 divided by 14 and bracket an equals, okay? Or you can do the 6 divided by 14 first and get that, okay, well that's 0.42857, right? And you could put in your calculator cos inverse of 0.42857, right? Use at least 4 decimal places if you're doing this, okay? And either way, once you do the cos inverse of that, you get a value for angle G of 64.6 degrees. Okay, so now we have angle G. The question also asks us to find angle H. Okay, now we could do this 2 ways. One way is using the property of triangles, in which you know that the sum of all of the angles in a triangle equals 180 degrees. And you could say, well, angle H is going to equal 180 minus 90 minus that 64.6, right? So 180 minus 90 minus 64.6, and say that angle H is 25.4 degrees. Perfectly valid way of solving for H. I'm going to show you the trig ratio way of how to do it, just because it's a new thing and we want to be able to show you. Okay, so I kind of restart, right? I'd erase my labeling on my triangle, or I'd redraw my triangle, up to you. And now I'm not interested in angle G anymore. Now I'm interested in angle H. So I label my triangle based on the angle I'm trying to find. So if I'm trying to find angle H, I'll relabel my triangle where directly across is the opposite. This will remain as my hypotenuse, and then this would be the adjacent. Okay? So now, looking at the side lengths that I have, I still have the 6 and the 14, but because I'm looking for a different angle and it changed the way I drew my triangle, I'm not going to have the adjacent and the hypotenuse side lengths anymore. Now I have the opposite and the hypotenuse side lengths. So which trig ratio involves opposite and hypotenuse? And that's the sine ratio. Okay? So now I can set up, okay, well, sine of H is equal to the opposite divided by the hypotenuse. And sine of H will equal the 6 divided by 14. Right? And then what I want to do is I want to get rid of the sine, so I do that by doing sine inverse. So I take sine inverse of both sides. Right? The sine inverse cancels with the sine, giving me just a value for H. So I can do sine inverse of 6 over 14, or sine inverse of 0.42857, and get my value of 25.4 degrees. Okay, so notice how the ratio was the same in this. Both were 6 over 14. However, by clicking the different button, I got 2 very different angles. Okay, that's why it's important that we use the right one. Because when we use that ratio, right, the cos inverse gave us a 64.6 degrees, and the sine inverse gave us 25.4. And that was the same answer that we would have gotten when we did the 180 minus 90 minus the angle G. Okay, so that's kind of showing you how important it is to be using the right trig ratio and the right button, because you have the same ratio, but it gives you 2 very different angles. Okay. All right, let's move on to example number 3. Okay, so again, you see that same work, right? Cosine there, sine of there, or just subtraction to get that same angle H. All right, example 3. So in this one, we have a bit of a word problem. Okay, so where are we going to be using this, right? We need to be able to figure out what angle we need to set things up at in order for it to meet regulation code, or whether it needs to meet a safety requirement, right? And we need to make sure that the way we've set it up fits that correct value. Okay, so in this case, we've got a 10-foot ladder. It leans against the side of a building where its base is 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? Okay, So the first thing we need to do is draw the diagram. So think about this scenario, okay? You have a 10-foot ladder that's leaning against the side of a building. So you have a building here, okay? And we have a ladder that's leaning up against the side. So here's our ladder. You don't actually have to draw the ladder, but just a line that you know represents the ladder. You know the length of that ladder is 10 feet long. Okay? You know that the base of the ladder is 4 feet from the wall. So the distance from the wall to the ladder is 4 feet. Now we're going to assume in this case that our buildings are being built straight and perpendicular with the ground and that this would create a right angle. And we've been asked, what angle does the ladder make with the ground? So this is our missing angle. I'm using that value of theta again, right? That Greek letter that stands for a missing angle. Okay, so this is our scenario. We have our right triangle. So once we've got our diagram of our right triangle, the next thing that we do is we label our triangle based on the angle we're trying to find. We are interested in finding this angle that it makes with the ground, so we label it, label the sides. So going directly across, this would be my opposite side length. Directly across from the right angle, this would be my hypotenuse. And next to it is my adjacent. Okay, so I've labeled my triangle. Now look at the side lengths that we have. We have the adjacent and the hypotenuse. Which trig ratio involves the adjacent and the hypotenuse, right? And again, if you ever need to, you can just kind of have SOHCAHTOA written at the top of your page, right? And adjacent and hypotenuse are here, and that goes with cosine. So we would set up my equation. Cosine of an angle is equal to the adjacent divided by the hypotenuse. We start filling in the values that we know, right? So we don't know the angle, so it remains as a theta. We know that the adjacent value is 4. We know that the hypotenuse value is 10. Okay? And what we need to do is we need to figure out this angle. So to get rid of the cosine, we have to do cosine inverse. Okay? So we do that to both sides. So cos inverse of cos theta is equal to cos inverse of 4 over 10, or just 0.4. Okay, so like I said, a cos inverse and a cos will cancel each other out. You're left with theta is equal to, and then you go to your calculator for this. I'd never expect you to be able to do this without one. Cos inverse of 4 divided by 10. Make sure you're putting those brackets in there, right? Or else it's going to do cos inverse of 4, give you an error message, and then you're going to be confused, right? So, or convert that to a decimal first and say, okay, cos inverse of 0.4. Okay, and either way, what you get there is theta is equal to 66.4 degrees. So very, very similar to what we had in our last example because the ratio was so similar. Okay, but there's the angle that we make with the ground. Okay, and that's how we find that missing angle. All right, oh, did it say, okay, nearest degree, so we would have rounded our answer here to 66, right? So, because the 0.4 would round it down, right? So it'd be 66 degrees instead. All right, let's look at one more example together, okay? And then we'll go from, and then I'll give you some time to do some worksheet stuff. All right, so I'll leave my SOHCAHTOA on my board. Let's look at this question. So a water bomber is flying at an altitude of 5,000 feet. The plane's radar shows that it is 8,000 feet from the target site. What is the angle of elevation of the plane measured from the target site to the nearest degree? So when we talk angle of elevation, we're just meaning like how much would you have, if you were standing on the ground, you had to look up at the plane, how much would you have to angle your eyes up? Okay, so again, the first thing we need to do here is draw our diagram. Okay, so altitude of 5,000 feet, that's straight up. If the radar is showing that it's 8,000 feet from the target site, radar is going to show how far is away just horizontally, right? Assuming that you're just flying over the top, right? It's looking at like a bird's eye view, it's 800 feet away. So what that would mean is when drawing our diagram here, right, if this is our plane, I cannot draw a good plane, but let's go with that, okay? This is our plane, and we know that it has an altitude of 5,000 feet. Okay, and the radar is saying that it's 8,000 feet from the target site. It's this value down here. Okay, and then if a person is at the target site, what's the angle of elevation? Looking up at the plane. okay? That's what the scenario is going to look like, okay? I mean, even think about that fact that, if it's a water bomber, it's likely not landing, it's just going to fly over and drop, right? So the 8,000 feet is how far does it need to travel this way, not on an angle, okay? So once again, once we have our diagram drawn, we can then label our triangle based on the angle we're trying to find. This is the angle we're trying to find, so we start labeling. So directly across from that is our opposite, right? Always directly across from a right angle is the hypotenuse. And next to your angle, it's not the hypotenuse, is your adjacent side length, okay? So we've got it labeled. We can see clearly that the values that we have are the opposite and the adjacent. So which trig ratio deals with opposite and adjacent? It's opposite and hypotenuse, not that one. That's opposite and adjacent and hypotenuse, not that one. Opposite and adjacent, that one. So it's a tan ratio here. So we know that tan of an angle is equal to the opposite divided by the adjacent side lengths. We don't know the angle, so we leave it as theta. So tan of theta is equal to opposite, which is 5,000, divided by the adjacent, which is 8,000. Okay, and we're trying to solve for this missing angle. So to undo a tan, we do a tan inverse. So I would do tan inverse of tan theta is equal to tan inverse of 5,000 over 8,000, right? So whatever you do to one side of the equation, you do to the other side in order for it to keep balanced out, right? So a tan inverse and a tan cancel each other out. So all you're left with is theta. This is done on a calculator. So again, what you could do is simplify that to just 5 over 8, or get a decimal approximation of 5,000 divided by 8,000 being 0.625, right? So if you wanted to, you could say theta is equal to tan inverse of 0.625, and then directly to your calculator, tan inverse of 0.625, and we get a 32-degree angle. There. Okay? So it's a different set of buttons, sine inverse, tan inverse, and cos inverse, okay, that are all being used to solve for missing angles. You still need the ratio of the side lengths, which means you need to have labeled your diagram correctly, and then you know which button you need to press to be able to find that missing angle, okay? So like I mentioned at the beginning, this is your last official lesson. Then what you have is a worksheet just practicing finding missing angles. There's an answer key for that as well, so you can check and make sure you're doing it correctly. Then you're going to have a little Google form quiz that will be posted on Tuesday for you to, just check off some multiple choice questions and fill in the blanks of, okay, yes, I understand how to find missing side lengths and missing angles based on, the lessons on trig ratios. And then you'll have your final Chapter 7 project. Okay, and that'll get posted, I think, on Tuesday as well, giving you some time to work on it. You don't have to have it done by Friday. If you want to, by all means, but if you need an extra, the rest of the weekend or an extra few days to kind of keep working on that, that's fine too. Okay, so that's it. That's as far as we're going to get in terms of the Math at Work 10 curriculum at this point. We unfortunately didn't get a chance to look at the financial chapter or the properties of angles chapter, but this is the stuff that the province has prioritized for Math at Work 10, right? They wanted to make sure you had all of the conversion stuff already done, and then they wanted us going into area and trig. Okay, so that's that. Good luck on your worksheets. Email me with any questions, and that is, right, so there's your notes again, and then, like I said, worksheet, and then that's kind of it from me.